We like to describe 5G as the new electricity. And there's some reasons for it, because connectivity has been the fabric of growth in our industry. And now we've gone from connecting everybody and their personal devices, mobile smartphone devices, to connecting everything. So I equate the cellular connectivity to the electric grid in the way that a smartphone is actually like the light bulb. It was the first mass application of electricity. And smartphone, likewise, is the first mass application for connectivity. But now we're going well beyond that, and that's creating enormous opportunities for growth in many different segments. And of course, with a new generation, we're also seeing a lot of additional growth in the core mobile industry. And just to quantify these opportunities, with a new G, 5G, reinvigorating growth in our core industry, we see a serviceable, addressable market of about $32 billion US in the core mobile business, smartphones and similar mobile devices. In addition, in that business, we see increasing growth within the RF, the radio front end. I'll talk a lot more about that later, totaling potential of about $20 billion of revenue in total in the industry. In addition, we've seen already massive growth in the areas like automotive, but also IoT and other adjacent areas where we're extending mobile technologies. A total of $66 billion of adjacent area opportunities for mobile technologies. But in all these opportunities, we believe 5G will be the connecting fabric for communications. I will be focusing most of this presentation on the mobile broadband opportunity for 5G. Among the three core segments, mobile broadband, Internet of Everything, and mission critical services. Rasmus will talk about in a bit more detail the more long-range opportunities in IoT and mission critical and automotive. I'm going to focus more on mobile broadband. And the three key value drivers for mobile broadband that I see are the extremely fast upload and download speeds for 5G as compared to 4G. We always get asked, what are the selling points for 5G? Why would I want 5G? Well, if you have 5 times the speed of upload and download, there's a lot more we can do with VR and other rich applications that you can't do today. In addition, it's not just about the individual user speed, it's also capacity. This insatiable demand consumers have for consuming data that's growing rapidly in order to keep the user experience improving. If you stop evolution, the experience deteriorates because traffic slows the network down, slows everything down. So we keep adding capacity to support unlimited data use cases. And of course, ultra low latency for whole new applications and new levels of performance you can't reach with 4G. And again, Rasmus will talk more about the technology aspects. We'll focus more on the mobile broadband proposition on this product presentation. With all these big benefits come additional complexity. As we like to say, no pain, no gain. In this case, what I want to point out is Qualcomm's expertise has always been harnessing the complexity of mobile systems, simplifying for our customers, the OEMs, and making the experience look really easy from the end consumer perspective. But this just gives you some examples of the additional layers of complexity as we go to gigabit LTE and the second ring of technologies to 5G and massive MIMO, ultra low reliability, the ability to connect simultaneously to 4G and 5G for this seamless transition. It's called dual connectivity. And of course, millimeter wave is part of the global framework for spectrum for 5G, radio spectrum. So I'll be talking about both the sub-6 gigahertz, lower frequency bands, as well as millimeter wave, but millimeter wave has its own unique challenges. And the two are very different. I'll tell you how we're addressing both of those challenges, but I'd like to summarize by saying 5G isn't just about RF. You're going to hear a lot about the radio frequency complexity later in the presentation. There's a lot of other complexity in 5G standards that we are commercializing as we speak. I didn't mention IoT or cellular V2X, which is being commercialized in the framework of recent 4G standards in the same timeline prior to 5G launch. When I say 5G is the connectivity fabric for everything that you see on here, Rasmus is going to explain how that's actually done, which is really the challenging part from a technology perspective. But again, this presentation is more about mobile broadband. About a year ago, we announced the industry's first 5G mobile chipset. And back in October, we showed that we achieved in multi-gigabit speeds. We're well beyond that now. And what I'm going to talk about in more detail now is the whole system of our 5G solution. What you see in the picture here is our baseband in the upper middle part of the presentation, or the slide. On the right, you see our millimeter wave antenna module, comprehensive antenna module. And I will pass around, with the help of my colleagues, either Karen or SS, our baseband chip. So you can see what we've packed into this tiny little platform. If I could we could pass this around to each table. I would encourage you, if you take it out, try to place it back in. It's so small, it's very easy to lose. That's why I have it in this container. So let's be really careful. We'll pass that around. That's the industry's first 5G mobile silicon. In addition, back in October, we announced the first smartphone reference design for 5G, and I have that model to pass around as well. Now, this is really the industry's first attempt to trial in a smartphone form factor. This may not look like your typical commercial smartphone, obviously a little bit thicker, but what we're doing is in an early stage of development where we still anticipate in our RF front end for millimeter wave more than 50% size reduction from what will go into this phone. We believe that we will drive the first 5.5-inch smartphones for both millimeter wave and sub-6 with a comprehensive solution from baseband to sub-6 to millimeter wave. And what we're showing with this phone is an innovative way to ensure robust millimeter wave coverage, which is really the challenging part from a coverage perspective in 5G. In this phone, you'll notice 3 openings on the sides of the phone where our millimeter wave module can propagate, send and receive signals. So let me pass this around, and I'll show you more about the architecture a little bit later in the presentation when we get to the RF section. So this device that we're passing around, I want to reinforce the main point. It's a 2018 trial device. Commercial smartphones with 5G using our solution, of course, will be much thinner, lighter weight than that device. But this is not our first experience with millimeter wave. We announced back in September and launched the world's first multi-gigabit 4G Wi-Fi device in the Asus Zenfone 4 Pro with 11AD. This device actually has a diversity module for the RF, the 60 gigahertz millimeter wave solution to provide more robust coverage, very similar to the approach we're taking in millimeter wave 5G. So in our evolution of Wi-Fi, we have evolved towards an architecture that we believe will give a superior mobile experience in millimeter wave for Wi-Fi. And then in these 2 prototype devices, our FPGA-based prototype, which has RF silicon in it, the piece in the middle. And Rasmus will show you a little bit more about the prototype system. And then, of course, the more commercial-like smartphone reference design on the right. And another way we're building the foundation for 5G launch is to continue evolving LTE. Our 2nd generation gigabit LTE modem, which is featured in the Snapdragon 845 mobile platform, gets LTE to 1.2 gigabit per second peak speeds, and proportionally the average user experience increases by 20%. One of the key ingredients to this gigabit LTE solution is the expansion of LAA, licensed assisted access, the ability to do LTE, gigabit LTE, and unlicensed spectrum, combination of licensed radio frequencies and unlicensed frequencies that are shared with Wi-Fi. This allows many more operators to launch gigabit LTE. In fact, well over 90% of all LTE operators with this solution can get to gigabit speeds, even if they only have 10 megahertz of licensed spectrum. So that's really the big breakthrough here, is the number of radio bands and combinations with unlicensed that can support gigabit speeds for LTE. This creates a coverage layer in 4G that makes the transition to 5G much less disruptive when a user roams out of 5G coverage. And this is more of a network picture of what I'm talking about in terms of building the foundation for 5G launch. So 5G will allow transition between 4G and 5G in a number of different ways. And it's important to create a very ubiquitous layer of advanced 4G so that the transition to the consumer looks very transparent. And so this basically shows you a picture of millimeter wave coverage in the densest areas for mobile broadband or even home wireless broadband, a much wider area of 5G NR in the lower frequency bands, which has better coverage, as well as gigabit LTE, because we know when 5G first launches, there will be coverage holes in many places. And then further extending out another layer of coverage at lower data rates beyond the traditional mobile coverage for IoT applications in new areas, deeper in buildings, out to unserved areas for environmental sensors and other new applications that require coverage even beyond cellular. LTE IoT standards are already doing this, and eventually that will migrate to 5G as well. And Qualcomm is also supporting the eventual migration to standalone networks. The vast majority of networks that will be launched in 2019 and even in 2020 will be known as non-standalone. The benefits are faster time to launch because you leverage the existing LTE network, which is very mature, very high performing, for all the critical control of the connection. You get higher initial bandwidth and user experience because you combine the capacity of 4G and 5G. And you have seamless transition for all the voice services and all of the handovers that have been optimized between 4G and 3G and 2G. So you have a very seamless and highly reliable voice service. And then eventually the motivation to move to a fully standalone 5G network is a function of having the new core network support this much wider range of services in one end-to-end network, from the radio network all the way to the core network. And the feature that enables that, one of the features is called network slicing. And that allows you to do everything from very low narrowband IoT type applications and all the way up to mobile broadband applications in one network much more efficiently. And the flip side is that once you move to standalone, you are relegated to just VoLTE and 4G fallback. So you have VoLTE as your only voice service in standalone mode. So that means your VoLTE network needs to be very, very mature and ubiquitous and highly reliable. And that's why we believe this will be an eventual migration path for many operators outside of Korea. Okay, now I'm going to talk very briefly about a business model disruption. I won't spend a lot of time on this slide because there's really no technology announcement, but I do want to point out that 5G as the new connectivity fabric will also disrupt existing business models as a result of cloud players and other players entering the ecosystem and having different requirements. Enterprises becoming much bigger, more autonomous customers that control their network infrastructure and their devices. So in this context, 5G will create new devices and use cases. Obviously, that's already happening with IoT. Many new deployment and business models, private networks, customer-owned networks, customers having more control of their devices, and of course the new ecosystem participants. Devices need to be more tightly integrated with the cloud and more secure. Some of the industries that will be driving this business model disruption: industrial security, energy and metering, industrial IoT, industrial handhelds. There's a common thread here. Industry, manufacturing, security. organizations that are not traditional mobile customers. They do a lot of these things over wireless LAN, Wi-Fi networks or over wired networks, and can't scale their businesses fast enough. So they have to move to wireless, but want more security, want more reliability, more flexibility. And it has to be zero-touch provisioning, zero-touch device management. It can't scale in the capacity that we're talking about. Millions of devices for launch, management, and monitoring and security. So this is the disruption that's coming that creates this big opportunity for industrial IoT. So what is required to address this massive opportunity? Global scale and high quality. So there isn't another company in this business that has larger scale and more proven quality and interoperability across more networks than Qualcomm. We've also pioneered some of the technologies that will allow for private networks through unlicensed IoT, multi-fire and unlicensed 5G. We've also, in our Snapdragon 845, moved to a much more secure hardware-based security, and we're going to continue to build on that security leadership to drive these new opportunities where security and reliability is significantly more demanding than in consumer cellular products. And of course, the suite of mobile technologies required is not just cellular connectivity, but a lot of these principles need to scale across Wi-Fi, Bluetooth, as well as advanced cellular. And some of the application processor capabilities, robotics, and AI also play into these opportunities. It's not just about connectivity, it's about the integration of intelligence and connectivity at the edge. So I'm going to move to the radio front end now. Talk about what we've done to establish our capability and how we're preparing for 5G. So why is the RF front end important? Well, to consumers, it's the reason if you have an efficient radio front end, you can have a very thin device that can roam anywhere, do it transparently to the consumer, have very good battery life, very good heat management so that you can stay within this very slim form factor, and have the kind of performance that consumers enjoy even when they grab the phone the wrong way and detune the antenna. So just to quantify this, the radio front end components can be up to 40% of the power consumption of a phone depending on the use case. That underscores the importance to the number one pain point for consumer, which is battery life. So I'm going to talk a little bit about that as well. So the radio front end is a series of components that's really part of a system, the way Qualcomm designs it, that sits between the radio and the antenna. And in the case of our 5G solution, includes the antenna module. And the radio front end, if you want to know simply what it does, it's like the plumbing of your phone that picks the signals out of the air, avoids them interfering with other signals that are sharing the same frequencies, and channels them in a way that transmits and receives with highly efficient power and the maximum performance. And so we have a number of components that come together to do that are depicted here. On this slide, we have some examples of OEM design wins that Qualcomm has had recently in major premium smartphones, showing examples of each component or module that we provide and which phones have adopted those solutions in the radio front end. As you can see, it's a really wide range of phones and a wide range of solutions that we provide across these platforms. I'll explain what some of these components do a little later in the presentation. Here are some of the most recent design wins we announced at CES. Phones from Google, HTC, LG, Samsung, and Sony. So next generation phones, including an end-to-end solution in some cases from Qualcomm. And if you want to see what components are in which phone after they ship, I would point you to the teardown reports of those phones. There are specialists that understand how to map all of the components, including the radio front end. But the two I'd like to focus on are the next generation Sony phone and HTC that will include end-to-end solutions, our modem to antenna solution. And so this gives you an idea of what's in those devices. And when we talk about modem to antenna, this is a system optimized solution that is able to maximize performance, reduce the footprint, and stay within the power envelope to save maximum battery life, especially with the use of the antenna tuner and the envelope tracker, which are two of the most important performance components in the radio front end. So preparing for 5G. The big challenge is not adding more frequencies, but the more combinations of frequencies in a feature called carrier aggregation, where we're adding many more band combinations. So if you have 50 bands, you can combine them in so many different ways to increase your data rate. In 4G, we have about 1,000 band combinations, and in 5G, that will explode to almost 10,000. I'm going to skip this slide because we talked about modem to antenna, and let's go right to the use of modem intelligence. For envelope tracking, that means we know exactly what the mobile wants to do in terms of its connectivity in frequency, power, in bandwidth, in modulation, and we can use that to adjust dynamically the voltage for the power amplifier, so we avoid wasting any energy. We know exactly what the power amplifier does need to transmit your signal, and so we can get to the ideal efficiency, which saves power, keeps the heat down, stays in the thin form factor, and more important, improves battery life. And the antenna tuner also uses modem intelligence to sense, and also sensors on the phone, to determine what is impacting the efficiency of the antenna. And we make adjustments in real time based on the modem intelligence as well. And that helps improve coverage, improves throughput, and also allow OEMs to design to new frequencies higher and lower without having to replace the antenna. So we can compensate for mismatches between the frequency and the antenna design. And so for sub-6 gigahertz 5G, how we're evolving this front end is we're accommodating more radio frequencies. We're accommodating wider bandwidths, up to 100 megahertz wide signal, and wider frequency range beyond 3.5 gigahertz all the way up to 5 gigahertz, and even below 700 down to 600 megahertz. And so we're adapting our antenna tuner for those capabilities, and also with antenna sharing capabilities expanding. And for our envelope tracker, which I just talked about on the previous slide, we're adapting that. We were the first with a 40 megahertz wide envelope tracker, and we're adapting it to eventually get to 100 megahertz wide for 5G to continue to improve the efficiencies of the power amplifiers as the signal gets more demanding. 5G is much harder because of the wide bandwidth and the high data rates to maintain efficiency and maintain power efficiency. That's how we're doing it in sub-6. Millimeter wave is a different problem. It's a coverage problem, and it's also a size problem. Coverage problems being addressed through beam forming. In this example, you see 4 antenna elements in the millimeter wave antenna module. That creates a beam that extends energy for lower power amplifiers. So we can stay with a low power amplifier with this architecture, and all the way to the right you see multiple modules. So we can actually have diversity. If you cover one with your hand, we can switch dynamically between those 2 antenna modules. So you get 2 levels of diversity. Diversity in beam forming, 4 antennas working all the time and forming a beam, and also switching between the 2 modules. And also it's an integration challenge, as I said, size. So we've come up with a new architecture that has baseband and IF in our baseband chip, and all the other front-end components packaged together very tightly in the front-end module, the antenna module. At CES, our president announced an initiative which is a first in the industry and a real breakthrough, which is the industry's first tunable radio front end for 5G. What we've done with modem intelligence previously has been independent optimization of envelope tracking, which is tied to the power amplifier efficiency, and independent optimization of antenna tuner. 5G is where it all comes together as a system with a dedicated controller that can optimize and take advantage of the gains we're getting both from the antenna tuner as well as from our envelope tracking and our tight PA and power amplifier integration to provide system level adaptability for any bands that are shared between, and components that are shared between 4G and 5G to maximize performance and to minimize power consumption. So the goal here is maximum performance, better throughput, better reliability, and longer battery life. And we can achieve this in 5G with our system level approach now with a fully tunable RF front end. And again, the emphasis here is on 5G multi-mode. So wherever you have shared power amplifiers and you have transitions between 4G and 5G sharing components, this is a huge advantage for OEMs and of course consumers. So as I start to wrap up here, this shows you the comprehensive roadmap for Qualcomm in all the key elements: filters and modules, antenna switches, LNA, PA, antenna tuner, envelope tracking, and the number of design wins we had back in 2016. We haven't updated that number. It's obviously we're well beyond those numbers now, but also some of the recent additions to the roadmap. BAW, as well as gas and gas hybrid PAs, and of course the tunable 5G RF front end, which has sparked a lot of interest among OEMs. I also want to summarize our advantages with a competitive analysis chart that we pulled together from third-party research. It shows you the comprehensive solution that we have and how it compares to other RF front-end suppliers in the industry. We know how the baseband players look in this area. Very few of them have RF front-end components in-house. And of course they can source them from multiple places, but putting together a system-level solution, as I described earlier, is a function of having control of all the IP in-house and being able to optimize the spec of each component and optimize the system design together and leverage modem intelligence. In fact, among these solutions, I think mostly it's just the power tracker that you'll see among the baseband suppliers in-house. And of course the transceiver and the modem. But when we look at the front-end components against front-end vendors, I won't mention them, but we'll take vendor A, which has made a lot of noise recently with regard to Qualcomm. Look at their footprint, and this represents the total capabilities. If they were to win designs for all of their components as compared to Qualcomm's footprint. This is a true system level design. This is driving the evolution towards the tunable front end. You need all these components designed as a system to optimize both cost, power, and performance, and battery life. Okay, and just in conclusion, we're driving the 5G RF evolution as RF evolution from a number of different angles. The system level approach we talked about earlier, integration, I don't want to lose sight of that, as that is one of the main challenges in millimeter wave, is the packaging and the integration. And hardware, software system co-design, particularly as it relates to the tunable front end. So we're leveraging an existing evolution. This sounds like a breakthrough, but it's something Qualcomm has been doing for a few generations already. But we've been doing it in the context of 4G, and we've been doing it in the context of envelope tracking and antenna tuner. Now it's all put together in 5G, which is going to provide some breakthrough advantages for our customers. So in summary, what I've shown is major growth not only in the existing core mobile business as a result of a new generation, but also in adjacent areas. Qualcomm's got the technologies that can drive all those opportunities. 5G is extending our technology leadership, principally due to the complexity and the challenge of putting all these pieces together and harnessing the complexity while maintaining performance, cost, and power efficiency. I showed you some strong traction we have in the premium designs for smartphones, for our modem to antenna RF solution. A lot more to follow. Stay tuned on that front. Our tunable front end, we think, is going to change the landscape for all sub-6 deployments, since virtually all of them will require 3G, 4G multimode capabilities and non-standalone solution. This will be a huge challenge that we're solving today. And of course, with the acceleration of standards, that put a lot of pressure on the commercialization. We're already showing proof of our advanced development of silicon, as well as the NR standards compliant testing that Rasmus will talk about in a lot more detail, expected by early 2019, and we are on track to be the first to drive the ecosystem to launch in early 2019. Thank you.